Okay, we're looking at chapter 16, body composition, obesity, and weight control. We're going to look at characteristics for the reference man, reference woman, body composition characteristics. Define lean body mass, fat-free body mass, and minimal body mass. We're going to look at Archimedes' principle applied to human body volume measurement. List assumptions for computing percentage body fat from body density. Explain how population-specific skin fold and girth equations predict body fat. Give strengths and weaknesses for the body mass index to assess excess weight, excess fat, disease risk. Describe the current status of overweight and obesity among American adults and children. List 8 significant health risks of obesity. Describe the criterion for obesity. Find fat cell hypertrophy, fat cell hyperplasia. Explain how each contributes to obesity and how change in body weight can modify these factors. Outline how unbalancing the energy balance equation can impact body weight. Explain the rationale for including regular physical activity in a prudent weight loss program. Explain how a moderate increase in physical activity for previously sedentary overweight persons affects daily food intake and overall energy expenditure. Explain the rationale for effectiveness of specific exercise for localized fat loss. Give diet and exercise advice to the person who wants to gain weight to enhance sport performance. Body composition, reference man and woman. So basically what this just shows is that total body fat is their average individual, the body mass, lean body mass, muscle, bone, and total body fat from a man age 20 to 24. And then reference woman, same thing, total body fat, and then it talks about what's the body mass in total, lean body mass, muscle, bone, okay, and total body fat. Essential and stored fat. So you need fat, okay? Essential fat is fat in the heart, lungs, liver, spleen, kidneys, intestines, muscle, lipid-rich tissues of central nervous system, bone marrow, including sex-specific fat in the female. Because obviously, fat is what? We talked about the four things. Fat is something that it carries the fat-soluble vitamins, vitamin D, vitamin E, vitamin K, and vitamin A. Fat serves as a protective for protection of the organs. Fat serves as an energy source, and actually fat increases satiety, where obviously the more fat you have, specifically eating it, then you're not as hungry because it takes longer to digest. But so you need fats in your body, okay? So but then too much of it's not good as well. So then you have essential fat, and you have storage fat packed primarily in adipose tissue. Fat tissue includes visceral fat, protects organs, okay, which is so fat that's deep in the tissues. And then you have and you also have subcutaneous fat, which is fat that's under the surface of the skin. Fat-free body mass, lean body mass. Lean body mass contains small percentage of non-sex specific essential fat, equivalent to approximately 4 to 7% of body mass. And then you have fat-free body mass, which is body mass devoid of all extractable fat. Okay, so these are two different things. You have minimal leanness standards. If you have men have less than 3%, then it can alter physiological function. And women, less than 12% can 3% and 12% is the minimal that each need to so that physiological functions could take place. So if you can calculate these through skeletal measurements. Body mass less than 20 percentile by stature, and then body fat less than 70% assessed by a criteria method that we'll talk about. So you have leanness, regular exercise, menstrual irregularity. Too much leanness, you have delayed onset of menstruation. Long distance runners and women long distance runners sometimes have this delayed onset of menstruation, or they have amenorrhea, which is absence, or the oligomenorrhea, which is the infrequent menstrual period. So Menstrual dysfunction results largely from changes in pituitary glands, normal pulsatile secretions, and luteinizing hormone, LH hormone, regulated by gonadotropin releasing hormone by the hypothalamus. Okay, so yeah, these are things that we talk about the hormonal section of the book that we went into previously, and some of these different things are secreted from the different areas of the hormonal responses. So you have the endocrine system that's releasing some of these hormones, and if you have this, if you have too much, regular exercise, too much leanness can inhibit these functions from taking place properly. So we talk about this luteinizing hormone and follicular stimulating hormone, things like that, and they're released from the pituitary anterior, which is directed by the hypothalamus. Okay, so this doesn't take place if too much leanness, too much regular exercise happens, which then causes this menstrual irregularity. Determining body composition. Two general approaches: determine fat-free components. You have direct measurement by chemical analysis or dissection, which obviously you're not going to do in a person that's alive. And then you have indirect estimation by hydrostatic weighing, anthropometric measurements, and other simple procedures, including body stature and mass. This talks about water, protein, fat, and ash and the remainder. But if we talk primarily about how much, your body's contains about 70% water, okay, and about 73.8 actually, and then reference body, and then 19.4% protein, 16.8% mineral. But that's reference, and so it varies based upon the individual. Indirect measurement, you have hydrostatic weighing, Archimedes principle. This is water displacement. So it interestingly enough, if you talk about this hydrostatic weighing, in the book, where are we at here? Page 527, you have an individual. Archimedes discovered the fundamental principle currently applied to evaluate human body composition. And what it is King Hieron of Syracuse, they wanted to see how much it displaced water, so they put it in a water bath, water flowed over, and then they were able to say, okay, this is how much water is displaced. So the volume of gold has a volume proportional to its weight. Okay, so what happens is densities of fat-free mass remain. The object is displacement. Okay, water displaces whatever you put a volume of something in water, it displaces, making the specific gravity of the ratio of the weight of the object and air divided by its loss of water and weight. Underwater weighing equation draws from the following. So the densities of fat-free mass remaining relatively constant even with variations in total body fat-free mass components of bone and muscle. Densities from fat-free mass components of body temperature 37 degrees Celsius remain constant within and among individuals. And then person's measure differs from the reference body only in fat content. And this is what this is here, okay? So you have this hydrostatic weighing, okay, where it's volume displaced, and then you're able to say, okay, this person weighs this relative to it. One of the things, what happens is the Siri equation is what is used. So you have the percent body fat equals 495 divided by body density minus 450. So you get that body density, you minus, subtract, minus 450, and then you divide the 495 by it. And then what happens is the mass of body fat is calculated by multiplying the body mass by body fat, by body percentage fat. So you have fat mass equals body mass times percentage fat divided by 100, and you subtract the mass of fat from the body mass yields fat-free mass. Okay, so you can get fat-free mass from this Siri formula. And that's Berkeley biophysicist William Siri, who collaborated with Dr. Albert Venke, working in Berkeley's School of Public Health. Okay, it's a way of converting body density measurements to body fat. Okay, and then ultimately fat-free mass. And that this is just talks about equations predicting percentage body fat from body density based on different estimates of fat-free body density of different individuals. Males white male 7 to 12, female 7 to 12, and then different, obviously 13 to 16, 17 to 19, 20 to 80, and then you look at other individuals in society of Native Americans, African Americans, Hispanics, Japanese, anorexic, and obese. Limitations, errors, hydrostatic weighing. You have density values of fat-free tissue, and fat tissue represent average values for young and middle-aged adults, but they vary among individuals and groups. So existing density to fat equations overestimates fat-free mass and underestimates percentage body fat for African Americans and Hispanics. One of the things with African Americans, you have to look at lean individuals and African Americans and say, they may have more fat-free mass than the typical population. Applying constant density values for the various tissues for children or aging adults introduces errors. The greatest source of error calculating body volume by hydrostatic weighing results from errors in residual lung volume, which is a large and variable gas volume that has to be subtracted to accurately determine body volume. Okay, and there's ways to do that. On page 531 it talks about it. Indirect measurement, BOD-POD. You have the plethysmographic device to assess body volume. And body volume equals the chamber's reduced air volume when the subject enters the chamber. Body density computes as body mass measured in air divided by body volume measured by BOD-POD. Okay. Sear equation converts body density to percentage body fat. We used that previously, and this is what happens. So you displaced air. Okay. Then you have skin fold measurements. Rationale for using skin fold to estimate fat composition results in the close relationship among subcutaneous fat, adipose tissue, fat tissue deposits directly beneath the skin, and the body's internal fat source. Body density of the intact human body. Okay. Skin fold calipers exist constant tension at the point of contact. Caliper dial indicates thickness of millimeters. Requires grasping skin fat with the thumb and forefinger, pulling it away from underlying muscle tissue, following skin fold natural contour. Skin fold is recorded within 2 seconds after applying the full force of the caliper. Another thing with that is you want to make sure that it's within 0.5 millimeters, because if it's too great on the caliper, then it's not giving you an accurate reading. So it needs to be within 0.5 millimeters, and you only hold it for within 2 seconds. Skin fold sites, if triceps, vertical fold at posterior midline of upper arm, halfway between tips of shoulder and elbow. Subscapular, so there's oblique fold below scapula's bottom tip. Suprailiac, so slightly oblique fold just above the hip bone, and the fold follows natural diagonal line. Abdominal, vertical fold 1 inch right of the umbilicus. You have the thigh, which is vertical fold midline of thighs, 2/3 distance from middle of the patella to the hip. Chest, diagonal fold, and interior axillary fold, axillary fold as high as possible. And biceps, a vertical fold at arms, upper arms, posterior midline. And this is just an example of what this is, and this is on page 534. 2 practical ways to use skin folds. You have some of individual skin fold values indicate relative fatness among individuals. Also reflects absolute percent change in fatness before and after physical conditioning or dietary regimen. Applying mathematical equations to predict body density or percentage body fat from individual skin fold values. You use age-adjusted general equations to predict body fat from skin folds that apply to the broad range of adult men and women. Skilled skin fold technician adheres to the following. You have to be precise in locating the anatomical landmarks for each prior measurement. So you have to make sure that you're measuring the same sites that we just mentioned. Suprailiac and subscapular, triceps, abdominal, thigh, things like that. Read a caliper dial to the nearest 1/2 marking. We talked about the 4.5 millimeters. Take a minimum of 2 measurements at each site. Use the average of the skin fold score. Take duplicate measurements in rotational order rather than consecutive readings at each site to avoid compression skin plus subcutaneous fat effect. So you rotate. You don't take consecutive, like 1, 2, 3 at the same site. You go through the whole process of all the sites and go back through. Skilled skin fold technician, here's the following. Don't take measurements immediately after individual stops exercising. So right after working out, it's bad for about 15 minutes because the shift in body fluid to the skin spuriously increases reading. Practicing, you should practice on at least 50 subjects, making multiple measurements on different skin fold sites to gain experience. You should obtain training from previously skilled technicians on how to take skin folds, and then measurements should be taken on dry, lotion-free skin. Indirect measurement, girth measurements. Basically, these are taken on individuals who have a lot of fat. So you are applying linear plastic measure tape lightly to the skin surface. So the tape is taut but not tight. Duplicate measurements at each site and average of the scores. You take girth, like I said, because the individual is not going to give an accurate reading in regards to the skin fold measurements. Okay. These relatively small prediction errors make population-specific girth equations useful to those without access to laboratory facilities like the BOD-POD and hydrostatic weighing, things like that, the DEXA, which I'll talk about. These equations should not predict fatness or individuals who appear excessively thin or who participate regularly in strenuous sports or resistance training that can increase girth without altering subcutaneous fat. So we're talking about hypertrophy, right? Okay, muscle size increases. Oh my, I'm taking this, and person's involved in resistance training, which is increasing girth, but it's not increasing fat. So you want to make sure that you're not using it with these subjects. Girth can analyze patterns of fat. Girth can analyze patterns of fat patterning, including changes in fat distribution during weight loss and gain. And then these are the ones that you use for girth: abdomen, buttocks, thigh, right upper bicep, and then right forearm and calf. You read through that. Okay, and that's I'll go over that. You can look at that. Indirect measurement, you have dielectrical impedance analysis, which is the current basically is two electrodes going through fat-free body tissues in water, and it's comparing with fat or bone tissue because of less impedance of fat-free component. Okay, so you have more you have impedance to electrical current flows relates to the quantity of body water, which in turn relates to fat-free mass, bone density, and percentage of body fat. Okay. You have a greater electrolyte concentration through hydrated fat-free body tissue, okay? So electrodes pass more rapidly through hydrated fat-free body tissues, okay, and extracellular water compared to with fat or bone tissue. So this deals with because you basically have greater electrolyte content or lower electrical resistance of the fat-free component. One of the things in regards to this is you want to make sure that the person's hydrated, because if not, it's going to overestimate. It's going to basically overpredict body fat in lean and athletic subjects. So it's going to underpredict fat in the obese. So that's one of the things. So impedance, okay, to current flow relates to the quantity of total body water, which in turn relates to fat-free mass, body density, and percentage of body fat. It requires standardized conditions in electrode placement, body position, hydration status, previous food, beverage intake, skin temperature, and recent physical activity. Bioelectrical impedance analysis tends to overpredict body fat. I talked about this already in lean and athletic subjects, underpredict in the obese. And that deals with, like I said, it passes more rapidly the current through hydrated fat-free body tissues. But if you're not hydrated, it's not going to pass as quickly. Okay. So what doesn't pass as quickly, it gives you more of impedance, more of the slow of the current, and that's one of the things that if you're underhydrated, it'll give you an overestimate of body fat. Okay. Underhydrated, yeah. If you're underhydrated, it gives you an overestimate of body fat. So if you're underestimated and you're an athlete, if you're underhydrated and you're an athlete, it's going to give you it's going to overestimate body fat because you have less water. And water, basically, the current passes more quickly through it. Indirect, so dual X-ray, dual energy X-ray absorption, DEXA, This quantifies fat, muscle around bony areas of the body, including regions without bone present. DEXA doesn't require assumptions about biological constancy of the fat and fat-free components. Two distinct X-ray energies penetrate into bone and soft tissue areas into a depth of about 30 centimeters. Specialized computer software reconstructs the image of the interlying tissues. Computer-generated report quantifies bone mineral content, total fat mass, and fat-free mass. Okay. So you have this right here, which is on page 539, which looks at the DEXA example of an anorexic woman. Two left images, and then you have the one on the right side. And the normal weighted women are on the right, and it just talks about the difference in numbers there, and the standard deviation, and basically what it's looking at is you're looking at his body. If you look at the body fat percentages, average about 25% of the total body mass. But if you look at the average anorexic subject who weighs 44 kilograms or 97 pounds, the DEXA estimates 7.5% body fat from the fat percentages of the arms, legs, and trunk. The values in the inset table present average percentage values for bone mineral density. Okay, which you see is much less. Okay, in the anorexic individual. So that's one of the things, the bone mineral density, and that's another thing that's a problem with in regards to anorexic individuals. Body mass index, you have this weight in pounds times 703 divided by inches squared. That really tells you how to gain that easily. And some calculators on your phone quickly too. You can type it in via Google search. But as the BMI becomes larger, risk increases for cardiovascular complications, diabetes, some cancers, renal disease. BMI does not consider the body's fat and non-fat components, so a high BMI could lead to an incorrect interpretation of excess body fat in lean individuals with excessive muscle mass. So you have individuals like, and I always reference this in class, you have The Rock, who's obese, and you have Vin Diesel, who's overweight. So if they have a lot of muscle mass, it overestimates. The BMI is higher, okay? So that's misclassifying someone as overweight, who is an athlete, bodybuilder, weight trainer, upper weight class wrestler, professional football player. So BMI, another interesting thing on this is it talks about disease level, okay, over 30, it's moderate, okay? Well, you have this, if you look at the lower end, you also have other issues. It's moderate if you have less than 20 BMI, okay? So, yeah, I mean, it's kind of interesting how that's on the lower end, too, that you don't want to have your BMI that's too low. Other indirect procedures to estimate body composition. Near-infrared interactants basically applies technology to the Department of Agriculture assess the body composition of livestock, lipid content, various grains. It's popular for health clubs, hospitals, weight loss centers. Unfortunately, the research with humans hasn't confirmed NIR's validity compared with hydrostatic weighing and skin fold measurement. It doesn't really it's not really a robust, valid method to assess human body composition. Ultrasound looks at sound waves, and it can assess thickness of fat and muscle, and image deeper tissues such as muscles, cross-sectional area. One of the things in the book, it talks about creams to apply to the thighs and buttocks to reduce cellulite. And so in regards to that, when looked at through this ultrasound, that failed to reduce local fat thickness compared to control conditions. Ultrasonography can also map muscle and fat thickness at different body regions and quantifies changes in the topographic fat pattern. Serves as a valuable adjunct to whole body composition assessment. Computer tomography is a radiation based. I mean, there's some radiation that you're given when you do it. It's a 2D X-ray beam, total tissue area, total fat, muscle area thickness, and volume of tissue within an organ. It basically it works okay well, but you're obviously getting that low dose of radiation, and then we also have this something in regards. It's the MRI is the imaging of tissue without radiation risk, soft tissue imaging, and with this, basically, you can look at internal fat and subcutaneous and internal fat among and within muscles. And there's an example of this on page 542 where you have this MRI. And what it does is it's figure 16.16, and so it can look at fat, muscle, the femur. And this, what happens with the MRI is the electromagnetic radiation in a strong magnetic field excites the hydrogen nuclei of the body's water and lipid molecules, and these molecules vary in concentration based on the tissue source. The hydrogens are, they're more concentrated in fat and less so in water and blood and least in bone. So then the nuclei then project this detectable signal that rearranges under computer software visually to represent body tissues. MRI can quantify total and subcutaneous adipose tissue in individuals of varying body fatness. The average values of for body composition, you have a young adult men average between 12 and 15% of, and then young women average between 25 and 25 to 28%. Okay, this is the average fat values for both. The trend of available body composition data for men and women of different ages indicates a distinct tendency for percentage body fat and steady increase with advanced age. Mechanisms leading to this increased body fat are not clearly understood, but they think it has possibly hormones and things of that nature decreasing over time. So one of the very important things is that physical activity can blunt body fat. Okay, this vigorous physical activity. It can maintain bone mass because you obviously have this bone remodeling, the collagen on the outside when you do weight-bearing activity that then turns into thicker bone, and then preserves muscle mass. So, in contrast, sedentary lifestyle results in increased storage fat, particularly in the abdominal region, and definitively reduces muscle mass. Okay, this occurs even if your caloric intake remains unchanged. So you have to do physical activity, specifically weight bearing and aerobic, to basically maintain this body fat composition so it doesn't go up. This just talks about determining goal body weight. Fat mass equals body mass times decimal body fat. Fat-free body mass is body mass minus fat mass. Goal body weight is fat-free body mass divided by 1 minus the decimal percent of fat desired. So then desirable fat loss presents body weight minus goal body weight, and that's on page 544. Definitions of overweight, overfatness, and obesity. You have overweight, which is overfat condition relative to other individuals of the same age or height, despite absence of accompanying body fat measures. Overfatness, which is a condition where body fat exceeds an age and or gender appropriate average of predetermined amount. And obesity is an overfat condition that accompanies a constellation of comorbidities, including one or all the following components: glucose intolerance, so the ability to not be able to eat glucose without issues, keeping it in the high blood glucose; insulin resistance, which is the inability of insulin to decrease that glucose to be uptaken by the cells; dyslipidemia, which is the the ratio of HDL and LDL is not proper. And then you have type 2 diabetes, which is, a direct effect from a problem that comes about relative to, obviously, having this insulin resistance, and then hypertension, which is the, systolic over diastolic, which is over, 140 or over 90. And then elevated plasma leptin concentrations, which obviously, leptin is released from the adipose tissue to send the signal to the hypothalamus to stop eating. And then VAT, which is increased the visceral adipose tissue, and increased coronary heart disease and some cancers. This is interesting here, and definitions: overweight, overfatness, obesity. So you have these states here. It shows. I mean, Alabama's one, West Virginia, and then you have, these are adults, and look at the children. I mean, you have the Mississippi #1, and then Alabama. I mean, 31.2% overweight. I mean, so this really has to do with, the WHO, the WHO, that talks about, World Health Organization talks about increased consumption of more energy-dense, nutrient-poor foods with high levels of sugar and saturated fats, combined with reduced physical activity, has led to obesity rates that have risen threefold or more since 1980. So it's not limited to the United States. We have these issues in the United Kingdom, Eastern Europe, Middle East, Pacific Islands, and even China, where about 1/5 of the 1 billion overweight or obese people are in the world. So about 1/5, okay, of the 1 billion overweight or obese people in the world are in China. So, this has to do with probably, this increased poor eating and also lack of physical activity, sedentary behavior, which is not surprising with technology and ease of use and things like that. So this talks about here these definitions. Okay, obesity is over BMI of over 30, overweight's 25 to 29. Remember though, this also has to do with BMI doesn't measure bone density or muscle mass. Those things have to be taken into consideration. So you have the DEXA and things like that. That yes, it's a little bit of radiation that's given off, but it's giving highly gold standard of a measurement of fat-free mass and fat mass and things like that. But it's also expensive to use. So you have obesity. What is that? Okay, you have, obviously, it's a complex condition, serious social, psychological dimensions. The impact all age and socioeconomic groups, threatens to overwhelm both developed and developing countries. 1.6 billion adults age 15 plus were overweight. At least 400 million were obese. By 2015, 2.3 billion adults will be overweight, and more than 700 million will be obese. 20 million children less than 5 years of age were overweight, which isn't unbelievable. It says basically in the United States that 1 in 5 American children is obese. It's pretty bad. Okay. And these causes include a complex interaction of factors, including genetic, environmental, metabolic, physiological, behavioral, social, and racial influences. Individual differences, specific factors predispose humans to excess weight gain, eating patterns, food packaging, body image, variations to resting metabolic rate, diet-induced thermogenesis, level of fidgeting, basal body temperature, susceptibility to specific viral infections, level of cellular APT, lipoprotein, lipase, other enzymes, levels of metabolically active brown adipose tissue. Brown adipose tissue, by the way, is better than the white. And it talks about that on page 551. Okay, brown fat, the good fat. All right. One other thing, too, is in regards to the FTO gene, which is really interesting. It talks about how everyone inherits 2 copies of this gene, this FTO gene. But children who inherit 2 copies of one variant of this gene were 70% more likely to be obese than those who inherited 2 copies of the other variant. And then 50% of the children who inherited only 1 copy of each of the FTO variants had a 30% higher risk of obesity. So this FTO variant didn't depress metabolism, but instead increased the tendency to eat more high-calorie foods in the test meals. Um, in each case, the extra weight was explained entirely by more body fat, not increased muscle mass or structural differences like being taller. So genetic makeup doesn't necessarily cause obesity, but it lowers the threshold for its development and contributes to differences in weight gain for individuals fed identically daily caloric excess, who are given more calories than needed. So genetic factors determine about 25% of transmissible variation in percentage body fat and total fat mass, and largest transmissional variation related to cultural effect. So cultural effect, it said about how you age is about 70% of how you age is based upon behavioral things, such as physical activity. You should be doing weight training and also cardiovascular activity, and also eating. Okay, and also just the effects of the stress and these other environmental factors. I mean, they're very important. Anyway, back to obesity. Average changes in diet lead to obesity, include shifts in dietary structure toward high energy density, with greater fat, added sugars, greater saturated fat, reduced complex carbs and dietary fiber, and reduced fruit and vegetables. So, carbohydrates are fine, but there should be complex carbs, oatmeals, things like that, fruits and vegetables. Phytonutrients that you're taking in, that have nutritional benefits. We talk about from the another thing is from the mid 1960s to late 1990s, daily kilocal per capita has been increasing globally by approximately 450 kilocal and over 600 kilocal in developing countries. Too many calories. And an estimated 75% of all U.S. adolescents eat fast food one or more times per week. And the thing is when they're young, when people are young and they're able to eat like this, the metabolism's high and things like that, it's fine. But then they get older and they're not used to doing physical activity and things of that nature, or curbing these eating patterns, and then they are more sedentary, let's say at a job or such. Then that's a problem. There's individuals even in Silicon Valley who sit all day, and if you think about it, those sedentary activities, looking on the computer, working, creating algorithms and computer-based programs and such, they're not moving. So it's a major issue. This is what talks about this global and regional per capita food consumption, kilocal per day. You have the world, and just need to look at 1964 to 1966, and then you look at 2015. Okay, it's 2040 versus 2,940, excuse me, compared to 2358, and it's showing you right there about 600 kilocalorie increase per day. Well, that's going to lead to what? Gaining fat. If you're not burning, and it's a twofold issue if you're not moving. Okay, the people back in 50 years ago were moving more too. Genetic makeup doesn't necessarily cause obesity, but it lowers threshold. We talked about that. Racial differences in food and exercise habits, including cultural attitudes towards body weight, helped explain greater prevalence of obesity among black women, either 50% than white women, 33. Also, too, in regards to this, there's something on page 552 you could look at. It's called the OB gene in adipose tissue, and what this talks about is the OB gene basically is a signaling molecule that's released from this adipose tissue to the hypothalamus that tells it to this satiety signal where we're full. Okay, it's another thing in regards to this the OB gene signaling leptin. OB gene creating coming out of inside the fat cell creates a leptin, goes from the fat cell to the bloodstream, goes to the hypothalamus, reduces or stops the drive to eat. So that's an interesting thing. When we talk too about these differences, if you look at the it's on page 552. Research in obese women shows that small differences in resting energy expenditure related to racial differences in lean body mass contribute to the racial differences in obesity. So you're talking about, is it decreased basal metabolic rate, or is it or lower amounts of physical activity? It's probably a combination of both. So regular physical activity through recreation or occupation effectively impedes weight gain and the adverse changes in body composition. Okay, so this is extremely important because if you think about it, okay, Like I've talked before, possibly I think I did in a previous lecture about the guy who's the logger or the lumberjack, okay? I mean, or the farmer, okay? We've moved away from those kinds of jobs in a lot of ways in our society. So that's an occupation, right? That where people get regular physical activity. Recreation, so is going to the gym or playing a sport or getting out there riding your bike, or that's another way to get regular physical activity, and that impedes weight gain and the adverse changes in body composition. Those are ways to do it. However, like I said, occupation may not do that for people as much, so then they have to do that recreation or physical activity each day, and obviously, they should be doing 60 minutes or more daily moderate physical activity, and the book basically endorses an increase to about 90 minutes of daily activity about 6 to 7 days a week to help combat this obesity epidemic in the U.S. population. Individuals who maintain weight loss over time show greater muscle strength and engage in more physical activity than their counterparts who regained lost weight. So it's you become what you do over time, right? So you form your habits, and then your habits form you. If you get involved in this lifestyle, it's a lifestyle to be physically active, eat healthy, things like that. So if you discipline yourself in these behaviors, what happens is that it becomes automatic because you become what you are. So if you're engaging in physical activity and you're engaging in ways of muscular developing activities, resistance training, things like that, and also aerobic activities, and eating healthy, you're going to delay the effects of psychomotor slowing and also the metabolism slowing because you're upkeeping all these things. Maintaining a lifestyle that includes regular, consistent level of endurance exercise attenuates, okay, so it interrupts, but does not fully forestall the tendency to add weight gain through middle age. You still may gain weight, okay, through aging, but it's going to mitigate those negative effects. Obesity continued. 10 major health consequences of obesity: of cardiovascular disease, type 2 diabetes, hypertension, dyslipidemia, ischemic stroke, sleep apnea, degenerative joint disease, some types of cancer, gallstones, fertility problems. Criteria for excessive body fat: you have 3 appropriate approaches to measure a person's fat content. You have percentage body fat mass composed of fat, distribution or patterning of fat at different anatomic regions, size and number of individual fat cells. We'll talk about that. Overfatness corresponds to any percentage of body fat value above the average value for age, gender, plus 5 percentage points. For young men, borderline obesity equals 20% body fat. For older men, body fat in excess of 30% represents overfatness. For young women, obesity corresponds to body fat above 30, whereas older women, borderline obesity begins about 37%. Okay. So young men, borderline obesity, 20%. Young women, above 30%. 2 types. You have the android or apple shape, and then peripheral, the gynoid obesity, which is pear-shaped. Android worse, basically, especially in regards to this central fat positioning. Hyperinsulinemia, glucose intolerance, type 2 diabetes, endometrial cancer, hypertriglyceridemia, hypercholesterolemia, so too much cholesterol, too much fats, triglycerides, a negative altered lipoprotein profile. Lipoprotein is basically cholesterol attached to protein in the blood, and then hypertension, atherosclerosis, which is hardening of the arteries. So apple is worse than pear. And this is it. Look at that. Apple, pear. Okay, apple's worse than pear. But both are not good. And then you dividing the waist to hip ratio, you divide the waist girth by hip girth, and then males above 0.9 equal to or above to 0.95, and females above 0.80 is the significant ratio for significant health risk. And that just talks about the BMI, waist girth, and BMI category, least risk, high risk, things like that. Okay, above men 102 centimeters, and then women, and then greater waist girth. You have men that are greater than 102 centimeters, least risk, And it's talking about also the waist girth in conjunction to BMI category and what the risk level is relative to that. So if you're a man with 102 centimeters and your BMI is over 30, you're a high risk. If you're a man that is less than 100 or equal to 102 and you have an overweight category, or let's say obese, let's say your overweight category is 25 to 29, you have a high risk. Okay. But again, BMI does not factor in muscle mass or bone density. So people who are overly athletic with muscle mass may not, their BMI may not be accurate in regards to, I mean, it's accurate, but it doesn't take into consideration bone mass, bone density, or muscle mass. Although not everyone's big boned. Okay, if you have too much added fat, too much fat on you, then it's not muscle mass. Then that's not what it is. Okay, it's that you have too much fat mass. One of the things here increases in adipose tissue 2 ways. You have fat cell hypertrophy, which is fat cell size, and then fat cell hyperplasia, which is cell number. Okay, one of the things is that it's known in obese individuals is it can't just be fat size; it's also fat number. So there's an increase in fat cell number in overly fat individuals, in obese, massively obese individuals. Cell number represents a major circular difference in adipose tissue mass between severely obese and non-obese. That's why I just said it's the hyperplasia. The number of fat cells is much higher in obese. Okay, so it's not just the size. Average person has about 25 to 30 billion fat cells. Moderately obese has 100 billion, and a massively obese has 360 billion or more. This just talks here about a chart that's on 559. Summarizing the non-obese's body mass and fat mass, and obese individuals fat mass and then fat mass. Their lipid per cell. Okay, so what's the cell size? Well, you have individuals who are obese. Their cell size is greater than individuals who are non-obese, but then the cell number is greater too. So they also have more fat cells than a person who is non-obese. Energy balance equation. So energy balance equation dictates that body mass remains constant, caloric intake equals caloric expenditure. Okay, ways to unbalance the equation to produce weight loss. You reduce caloric intake below daily energy requirements. Maintain caloric intake, increase energy expenditure through additional physical activity above daily energy requirements. And then decrease caloric intake and increase daily energy expenditure. Okay, and this just talks about here about weight gain and weight loss. So how does it happen? Well, you either increase your energy expenditure, or you decrease your energy intake, which is food. Or you could decrease your energy, food, and also increase your energy expenditure, which is more beneficial. Okay, so you could do both. All right. In talking about that, continue on. Set point theory. This is a genetically determined set point for body weight or body fat exists that differs from what the dieter would like. And what this means is that people have a well-regulated internal control mechanism deep in the brain's lateral hypothalamus, so that if you don't eat enough, your body starts storing more fat. If you eat too much, your body burns it, which is a theory that, the internal adjustments that affect food intake and regulatory thermogenesis resist the change and conserve or replenish body fat, meaning you don't lose weight. And this talks about fat cell size and number after weight loss. This just talks about how, like, an individual who is overweight, the number of fat cells don't decline, but the size does. Okay, so in adult onset severe obesity, new adipocytes develop in addition to hypertrophy of existing cells, meaning that there's more cells that are added. Okay, in severe obesity, but what this speaks to too as well is that when you lose weight, you're not decreasing the number of fat cells, you're decreasing the size. Okay, which can go right back up if you don't, if you increase your caloric intake and do not maintain your caloric expenditure. Emphasize carbohydrate restriction while ignoring total calories, cholesterol and saturated fat. So this diet, the ketogenic diet, basically, you're cutting carbs. The major problem with cutting carbs is that carbohydrates is a primary energy source for high impact, high intensity physical activity. Okay, or long distance high intensity activity. So you need carbs for energy during performance. And so some of the negatives is that the serum and uric acid levels are raised, which is a problem because then the water takes out the uric acid, which you lose water. Okay, water, it talks about here, alters electrolyte concentrations, initiating cardiac arrhythmias because electrolytes are water and minerals, and if you don't have potassium, sodium, things like that, it can cause cardiac arrhythmias, and you don't have those things because you're cutting out the water which is needed to form with minerals to create electrolytes. You also potentiates development of kidney stones because you have too much solutes and not solvent, which is water. Causes acidosis because basically you have this increase in uric acid, which causes more of an acidic state, which is lower than 7 pH. Then you have aggravates existing kidney problems from extra solute burden, renal filtrate, and then it's to filtrate more solutes. And then you have depletes glycogen reserves, which causes fatigue because you need glycogen to basically do physical activity, especially if it's intense. And then decreases calcium balance and increases risk for bone loss, causes dehydration because increase in protein, like I said, you have to take out the uric acid. And also carbohydrates are 2 to 3 parts water, so you're losing water in a doubly. And then retards fetal development during pregnancy from inadequate carbohydrate intake, which is really bad. So if it's going to retard fetal development, what is it doing to us, to individuals on it? Diet plans, high protein diets, may shed pounds short term, but long term success remains questionable, may even pose health risks. Protein rich foods contain high levels of saturated fat, increasing risk for heart disease, type 2 diabetes. High protein diet has potential to cause strain on liver, kidney function, accompanying dehydration. You have electrolyte imbalance, glycogen depletion, lean tissue loss. You have semi-starvation diets here. Talks about very low calorie diets, benefit severely clinically obese individuals, body fat exceeds 40 to 50% body mass. Provides between 400 and 800 kilocalorie of high quality protein, applicable meal replacements. Needs close supervision in hospital setting usually. Proponents maintain severe food restriction breaks, establish dietary habits, which in turn improves long-term prospects for success. Most individuals, semi-starvation doesn't compose an ultimate diet or proper approach to weight control. So most people this doesn't work for. And it's short-term, all this stuff, because they always go back to what they did previously. That's one thing with diets. It's a high percentage. There was one study, I think it said out of 200 people, I think it was 7 people after 5 years maintained the diet or maintained their weight, should I say, based upon whatever they were doing. So diets are short term. What you have to do is it has to be a lifestyle. People ask questions. How can I lose weight and keep it off? Well, you increase physical activity and then you eat more healthily. Now, you don't have to eat healthily all the time, but you remember, it's like a bank card. You put money in the bank, you take money out. If you are eating donuts, you have to think, oh man, how much calories are those in those donuts? I better do this much more physical activity for the day than I usually do to burn off the donuts I ate. And then you'll think twice about how many donuts you eat. There's nothing wrong with having a donut here or there, or pizza here and there, or whatever, but you have to think about what are you eating? What are the components of what you're eating? And does it make sense? And you can do those things, but you have to think about, like I said, the offset of whatever that it is that you're doing, the cost benefit analysis. So strategies affect weight loss, hydration level, duration, energy deficit among. So this just talks about the initial weeks. Okay, um, the first week when you're restricting calories, things like that, you're losing water. 70% of water loss happens in the first week, and then after that, it's 20% up until the fourth week, and then you start losing fat. Okay. And that's what this talks about here. Week 4, week 2, 3, week 1. Week 1, 70% water. Week 4, okay, fat percentage, 85%. Okay. Exercise misconceptions of weight loss. So you have increased physical activity and food intake. A weak coupling exists between short-term energy deficit induced by exercise energy intake. Okay. Increased physical activity by overweight, sedentary individuals does not necessarily alter physiological needs and produce compensatory increases in food intake to balance out additional energy expenditure. So, it's like, well, I'm eating more, I'm working out more, so I eat more so that I don't, lose weight. Well, first of all, too, you want to see how much what you're eating, and then also is that replenishing what you lost through that physical activity. You should be eating complex carbs, protein, if you're breaking down protein through weight training, things like that. And even if you're running, you need protein. So within means, proper percentages. But you're not exercise also has an effect of where it causes you to be it's a hunger suppressor. So you might get hungry after you work out, okay, but it's not gonna. It's still you're still and you need those macronutrients and micronutrients in the food to basically counterbalance you working out anyway. Okay. Another thing is low caloric stress and physical activity, which is the calorie expending effects of increased physical activity at and a caloric deficit of 35 kilocalorie equals it's 40.45 kilograms or 1 pound. Okay, whether the deficit occurs rapidly or systematically over time. So you end up probably burning more than just that. So the second misconception concerns the negligible contribution to weight loss of the calories burned in typical physical activity. So, they say, well, how much am I I have to burn all this, and how am I gonna, but it's also during the day. So if you're doing, so if you're moving around, so that's why they also say that physical activity adds up over time. Okay, is what they're talking about. Even chewing gum burns about an extra 11 kilocalories each hour. Okay, which is a 20% increase over normal resting metabolism. So everything you do, and basal metabolic rate, things like that, can be increased through physical activity. But also, even digesting food, even causing your body's burning calories by functioning, brain, stomach, walking, moving, all these different processes that are automatically taking place are also burning calories. Effectiveness of regular exercise. Adding physical activity to weight loss program favorably modifies composition of weight loss. So one of the things that's talked about in here, it's on figure 16.34, is that fat mass. So basically diet and exercise was the most beneficial in regards to losing weight, secondarily to diet only. But the issue is that if you're exercising, you may not lose quite as much weight because you're maintaining fat-free mass or muscle mass. So you're losing more weight through diet only, but you may be losing fat-free mass, which is muscle. So diet and exercise has been shown in a lot of ways to be the most effective. So that's basically what that talks about there. Okay. Spot reduction. This is some other thing that people think about. Oh, I'm going to do abs and my abs are going to lose fat on top of my abs. Okay, subcutaneous fat. Well, no. Okay. Fat deposits are basically the exercise stimulates mobilization of fatty acids via hormones and enzymes active on fat deposits throughout the body, not simply from areas closest to the active muscle mass.